In these problems, we're dealing with chords of circles and intercepted arcs. Chord is a line that goes from one edge of the circle to the other. And one of the properties of chords that you should know about is that if you have a line that comes from the center and intersects the chord at a right angle, it bisects the chord, so it cuts it into two equal parts. So in this particular diagram, I see I've got the distance from A to D is 15, so I know from D to B is also going to be 15, so I'll just write that in. Now what we're trying to do here is find the length of OD. So how do we do that? Well, at first it might look a little bit impossible, but what I'm going to do is actually draw in a line that isn't here. I'm going to draw a line from O to B, and that does two things. It creates a right triangle here, so I might have a chance of using the Pythagorean theorem to solve for OD. And also, it creates a radius. If you draw a line from the center of a circle to the edge of the circle, you've got a radius. And I've actually got another radius already on this diagram. O to C is a radius, and that's labeled as 17. And since every radius of a circle is going to be the same length, I know this side is 17. Now I've got two sides of a right triangle. I can definitely use the Pythagorean theorem to solve. So this would be, let's call this side A, and we would have A squared plus 15 squared equals 17 squared. And let's see, that's A squared plus 225 equals 289. We'll subtract 225. We get A squared equals 64. And we'll take the square root of both sides. And we're going to get A equals 8. So OD is 8. All right, let's try another one. This is a lot like that one. We've got a slightly different diagram, but we've got two chords here, EF and CD, and notice that they're bisected by these lines that perpendicularly intersect them from the origin of the circle. The first part here says CD equals 68, so this chord is 68, but since I know this is bisected, I'm going to go ahead and divide that by 2 and call CM 34 and DM 34. And let's see, we have OM, so I'll put that in, that's 16. And ON is 18. And we're trying to find EN, so we're trying to find this side right there. Well, this is going to take a little bit of work, but I'm going to do the same trick I did last time. I'm going to draw in a line here, a radius from O to C. And in this case, I'm going to solve this right triangle that I've created to find that radius. So that would be 16 squared plus 34 squared equals C squared. Our radius is the hypotenuse in this case. And that should be 256 plus 1,156 equals C squared. So C squared would equal 1,412. I don't think this one's going to come out evenly. So we've got C equaling approximately 37.58. And now we're going to use this over here. I'm going to draw in another radius, and I know that OE here is the same length because it's a radius. So now we'll use the Pythagorean theorem to solve for EN. And so we would have 18 squared plus B squared, which is our EN, equals, well, I guess I didn't need to go ahead and take the square root of that because I'm just going to square it back up. So I'll just put it in here, 1,412. That's C squared. And then let's see, 18 squared is 324 plus B squared equals 1412. And we'll subtract 324 from both sides. And I think we get B squared equals 1,088. We'll take the square root of that, and we get B equals 32.98. Yeah, we'll call it that. All right, one more problem. This next one's about intercepted arcs. And in this problem, we're told that DAB, so this angle right here, and DCB, this angle right here, are right angles. So we've got 90 degrees here, we've got 90 degrees here. What that means is that this side of the circle is 180 degrees, and this side of the circle is 180 degrees, because these are inscribed angles. So the arcs they intercept are going to be twice their measures. So that makes dB a diameter of the circle, and it cuts it right in half. And then it also says the measure of ADB, so this angle right in here, is 71. So that means that this portion of the arc there, that angle intercepts, is going to be 142. And we want to find the measure of arc ACD. So if we were going to do that, we would go from A all around to C, all around to D. So everything but that little portion right here, so we don't want that included. So how are we going to do that? Well, I know that this distance from the arc from B all the way around to D would be 180 degrees, because I've already determined this is a diameter here. So if we subtract 142 from it, we would get 38. So this little bit of an arc right here is 38. And then since we want everything else other than that, we're just going to have 360 minus 38. And that's going to be 322. And that's the measure of the arc length of arc ACD. So that's a little bit about chords and intercepted arcs.